Woo indeed. Hello and welcome to another exciting Breakfast with Unity. I'm your host, Max Moreau, and today we're going to be doing some rotation and translation practice in the form of a remote control robot, kind of a Roomba robot thingy. So, we're doing this because there was a request. I always do this. I never look up people's names. But there was a request on one of the last videos to do more rotation translation stuff, just kind of the basics. And so that's what we're going to do on this one. So first we're going to need a robot, though. So I've already created a scene. Remote control robot is in 70 remote control robot here. Nothing special other than we created it. And so we're going to first start by making our little robot. So I'm going to make a cylinder. As I said, we're going to kind of make this little Roomba robot. Really simple thing. I'm just going to put it at 000 for right now. And we're going to make it 0.1 tall, and there we go. We're practically done. What we're going to add, though, is we need to be able to tell which is forward, so I'm going to add some googly eyes. So we're just going to create another, let's do another cylinder. Let's do them cylinder style. So we'll do 0.01 this time. And make this a lot smaller, like 0.25. I don't know. 0.25, is that big enough? Is that small enough? All right, so what are we going to do? So let's create a couple of materials real quick. Material, black. Yeah, we'll just create black. We'll put it as black, and we'll make it. I forgot to add those things. Someone actually gave me a nice unlit where you can set the color, but I forgot to put them in a useful place. So I'm just going to use vertex lit. That's not going to help. All right. Yeah, it doesn't matter. So we're just going to put this down. Actually, let's go ahead and make the other eye. I'm just going to duplicate this cylinder, make it even smaller. The other eye, I mean the pupil, and put it up a little bit. Just kind of stack it on there. And this one we will actually make black, so we'll just throw that on there. And now I've got kind of a thing here. I'm going to just give the robot a different color so that we can see the eyes better. So I'm going to just create a material. We'll go with green. And make it kind of a forest green. We'll not do full green. There we go. And I'm going to go ahead and make this a child of the other. Whoops. And we'll place it on the robot. Whoops. Place the whole thing on the robot. Actually, this is probably a good place for if you hold down Command, I think it is. No. If you hold down Shift, there it is. Does that do what I want it to do? No, it's not doing it. Oh, I see. There's a sphere collider. That's the reason that we have a problem here. Because the collider is so big, I can't just use the snap to surface thing. So I'm just going to move it down. And then, so we've got the X. We'll set that as 0 for right now. The Y will do 0.1, Z 0.225. And then we will now move it so that it's like 0.2. And then we'll duplicate it again. And then just do positive 0.2. There we go. We have a little robot. Yay. So, so I'm going to call this a robot. And we're going to place these things inside the robot. And we'll call this an eye and an eye. I'm not going to bother renaming the pupils to pupils. You'll be able to figure that out, I'm sure. All right, so let's actually get this guy moving. So we're going to create a C# script. I'm going to call this... this time I'm going to do both the rotation and movement behaviors in the same script. We're going to call this remote control robot. We could do these as separate scripts, but today I just felt like doing it as a single one. So what we're going to do, consider we already have some similar scripts for doing this type of stuff. So what we're going to do is we're going to have a public float speed equals 10. I'm going to make it 10.0 f. We're going to go bigger than we usually do on the default. Actually, let's make it 5. Let's go with public float rotation speed. And we'll do this in degrees per second, so I'm going to default it to 60.0 f. And yeah, do we need anything else? That's probably all we need. So first off, the forward and backward movement. This is the easy part. So forward, backward movement. So this is really, really simple. So we can do this in one line. It's just transform.position plus equals transform.forward times input.getAxis or vertical times time.delta time, and we need a speed in there at some point, times speed. It doesn't matter what order you put these in, I just like to put time.delta time at the end. So this should make it so that if we attach this script to our robot, we can move forward and backwards, and I'll explain why in just a moment. So if we attach this to the robot and hit play, and actually I'm going to make the, I'm going to change where the camera is. I'm going to do this, and I'm going to tell the camera, we're going to go game object align with view. There we go. So now if we hit play, we should see, oh, we should put a light in the scene. Create 3D, create directional light. There we go. That'll help. So we've got a little robot, and if we hit W, nothing happens. Did I put the script on the robot? I didn't, evidently. I swear I dragged the script on that robot. Where did it end up? Okay, I must have forgotten somehow. Okay, whatever. I'm dragging it on now. Hit play. And if I hit W, it goes forward, and if I hit S, it goes backwards. So the reason this is working is because we're doing some basic linear algebra here. So we have transform.forward, and then we scale this. These are all scalars. So this is a vector 3, and the rest of these are just floats. And what we're doing is transform.forward represents this blue vector here. That's the forward vector for the robot. So whatever direction it's pointed in is the direction you will get when you go forward and backwards. This vector is a unit vector, so it's one. So when we get transform.forward, this is 1 unit long. So if we multiply it by anything, it becomes that number. So if you want it to go, if you want to change the position by a meter, or by a unit rather, you would just do transform.forward. If you want to do more than that, you would multiply that in. So we multiply in the speed and time.delta time to get the amount that you'd want to go forward. If we just did that and we didn't have the getAxis portion, this robot would just move forward at 5 units per second. So if we hit play, you'll see that he's going forward at 5 units per second forever. But with this, we can actually move forward and backward. And this is because this represents a number between -1 and 1 based on the state of the joystick or your keys. And so because of this, if you press backwards, you'll get -1. It turns this to negative, so it points in the opposite direction, and you start moving backwards. And if you have an analog controller, this will actually give you an analog result for your movement. So that's the basic movement. Time.delta time, also, just going to say it, even though we've gone over it before a lot of times, but what it does is it makes it frame rate independent. So if you multiply time.delta time, this means units per second. If I don't multiply that in, I get units per frame, and so it will move 5 units every frame, and it will be gone before we can even see it. Or not. Oh, wait, yeah, if I hit forward. Yep, there it goes. It went real fast. It goes 60 times faster, basically. So we want time.delta time there, so that way if we drop frames, everything will still move the appropriate amount and stuff. So now we're going to do rotation. So the rotation is also super simple. We're going to use transform.rotate. And it asks for Euler angles. There's a few different versions. There's axis angle and stuff. So since we're just rotating along, we're basically just want to rotate the Y. So we're just going to have the Y component. That's all we're going to do. So rotate, and we give it a, and I think there's one that just allows us to put the angles in. Yeah, perfect. So we're just going to do 0.0f, 0.0f for Z, and then for the Y value, all we're going to do is rotation speed times time dot delta time. This one will make it so that it just rotates in place at all times. So if we just hit play right now, you should see the robot rotating. So he's rotating, and if we hit forward and backward, he still moves forward and backward. That's cool. But we want it to be based on input. So we're going to just throw another input in here. So this is input.getAxis horizontal. Horizontal. These names are defined in the input manager. I'm going to show you where that is real quick. Right now in this project, they're defined to WASD. So if you go to project settings, input, you'll see that horizontal is A and D, and vertical is set to S and W. In our project, we also have vertical 2 and horizontal 2. This is when we did the split screen project, and those are set to the arrow keys. So you can use those instead if you'd prefer. You can also easily set this up as a variable in just a public string. So there we go. So if we hit play now and do WASD, we should have a little remote control robot. Yay! So you can go forward and backward and make little turns and little curves and stuff. So let's give him a little trail renderer and call it good. I'm just gonna throw a I'm just gonna create a empty child here, throw it on the back here, somewhere around there, and we're just gonna put component miscellaneous. No, what is it called? Effects trail renderer. There we go. And let's just see how this does without changing any settings. Yay, he has a trail. Let's make it so that it actually doesn't look terrible, though. So I'm going to make the trail a lot shorter. It doesn't matter. So the main thing is it needs material. I'm just going to give it... I'm going to give it the green. Actually, I'm going to duplicate the green and make bright green. Throw that on here. We're going to put into materials, we're going to put the bright green, and I'm going to have the end width be 0.0f or 0.0 or just 0, I guess, and we'll make it so that it's 1 second long, and then we hit play, and now we have a little cool trail for our little dude. Yay! Hooray for robots. I'm just going to stick this a little bit further inside of them. Actually, I'm just going to put it 0, 0 and see what happens. We get some clipping on certain angles and stuff. I'm not sure if I like it. Actually, part of it might just be because the initial width is just way too much. Let's just do 0.5. Yay! All right. Still too much, but yeah, you get the idea. I guess we could also put it underneath them slightly, so just like negative 0.5. Whoops. Negative 0.5. Yay, alright. Now we have a little remote control robot. You can go backwards, forwards, and you can rotate. Save scene, save all, save project. Thank you very much for watching. If you have any questions, please email me, pushypixels@pushypixels.com. You can also tweet me at Drakfyre. That's DRAKFYRE. Thank you very much for watching. Please support us on Patreon. Please donate through Patreon, patreon.com/cookingwithunity. Really appreciate your support. Great one, and I will catch you tomorrow with more Breakfast with Unity and some scape action. Alright, that wasn't too bad. Nice, simple episode. Is there a way to create gravity based on the reverse direction of normal so I could create weird shapes in 3D program and export them and the character would be able to walk around them? Yeah, I mean, yeah, that should be possible. It's you wouldn't want to change the gravity settings in the in the physics stuff, but you could do it where the player just automatically gravitates based on the nearest surface normal, just by doing a raycast down or something, or a raycast out. We do some complex stuff with this on the Mario Galaxy episode, where we actually do some of the calculations ourselves. That's the kind of thing that you're probably going to have to do. It would be hard to wrangle the actual physics system to do this, but it would be pretty easy to set up a non-physics based solution for that. How hard it is to create an after image? So you mean like when you're like a blur or an after image type thing? So depends on what you want to do. Easiest way is pretty easy. We could just create another, just duplicate the robot, make it semi-transparent, move it behind. This is not a perfect example. I'm just going to do it real quick. We're just going to change the. Just going to duplicate all of these, make them transparent. So this is the simplest way you can do it. We're just going to go and make all these like 50% alpha, 50% alpha, and 50% alpha. And then we're going to apply them to our other robots. So black one, yeah, it doesn't matter, I'll just put green. I'll just do the green one. We're not going to worry about the rest of it. So if you did that, then we'd have like, you could have a after image type thing like that. This is not perfectly set up, obviously. Both of them have the AI, and they're not doing exactly what we want. We actually want them to follow each other and things like that. But that's one way to do it. Another way to do it is if you have Unity Pro, you can do you can re-render a portion of the screen, or just basically the character, and then redraw them with 50% transparency. There's you could do like a motion blur type effect. That would also require Unity Pro. Basically anything that you're modifying pixels that aren't part of the object itself, then you're going to need Pro. But yeah, it's not terribly hard. There's just a few different ways that you could do it. All right. Have we made a pause button yet? I don't think we've done a pause button specifically. So we should probably cover that at some point. And by the way, this is Max. I'm Max. I think. Or are you talking to another Philip that's in here? Sorry if you're talking to someone else. So yeah. Anyway, I will consider a pause episode at some point. That's actually a good idea, and it's really, really common case. So, see you guys later. Have a good one, and yeah, I'm excited about Unity 5 as well, and ZBrush is awesome, and yeah, see you guys around.